All right, talking about work. You've probably used the word work many times in your life. However, in physics, it has a pretty specific meaning. If you look up here at the top, my definition says the product of the magnitude of the displacement times the component of the force parallel to that displacement. So I've written down quite a few different equations here for work, simply because you might see it in many different forms. Now, the most basic form that I like to use is just saying work is equal to the force parallel, that's at the two little lines, it's not to the 11th or subscript 11 or something, force parallel to the displacement. So you could see it in another form where we use delta x instead of d, or very common in IB versions, they like to use s, or in AP versions sometimes they like to use r. Okay. Either way, the most basic form is the force parallel to the displacement. Slightly more advanced version of these involve an angle. Especially if you're pushing at an angle to a horizontal or something like that. Only a portion of that force is actually doing the work. The other part is not. So you might see things like work is F d cosine of theta, or this is the AP version where work is F times delta R cosine of theta, and this would be your IB version. So I'll write these down. These are on your packets. So if you need them, that's how you're going to identify them. Now, one thing that I should point out is that if you use cosine of 0, 0 is indicating that you're moving in the same direction as the force is pushing. And if you were, say, using friction to slow something down, then the friction would be acting opposite the direction that it's moving, so it would be at 180 degrees. This also comes in handy when we talk about if it's positive work or negative work. Okay? So right here, there are units for work. Again, if you multiply a force times a distance, okay, force times displacement, forces in newtons, distances in meters. However, there's a different name for that called a joule, which you've most likely heard in your life. So units for work are joules. Okay. So I've written down some examples here that I want to go through. Lifting a book. Is it doing work if you're lifting a book? Well, let me see. The book itself has weight, and we are raising it up in the air in the same direction, a parallel direction as the force. Therefore, yes, you'd be doing work. For this one, walking with a book. Now let's write this down here. Let's go right. Yes. Okay. If I was just walking holding a book, am I doing work? Well, if I was walking, then the book would be moving horizontally, whereas the weight of the book is acting vertically. Therefore, if they're not parallel to each other, then this technically isn't doing work. Now, we could dissect that a little bit more, but for this particular thing, let's just say no. Dragging a book. Okay, well, if I'm dragging a book, pulling it across the page or something like that, then the force is moving in the same direction. At least the applied force is moving in the same direction as the book. So if they're parallel, then yes, you're doing work. And then also if you're dragging it at an angle, and I want to talk about this. So if I drew a little picture where I was drawing the book at some angle like this, pulling along a surface, okay, it's going to move from here, and we'll say this is the displacement right there. It's going to move a certain distance, meaning there's a component here of that force that is parallel in the same direction as the displacement. And now you can kind of see where, say, that angle would come back in handy. Whatever this force is, if I want this component, it's the adjacent side of this triangle. Therefore, it's the cosine of the angle. That'll give me that particular component force. Okay. Now, going back a little bit to this unit for work being joules. You've most likely heard the term joules when you were talking about energy at some point in time. So energy and work are directly related. Okay? Matter of fact, energy is defined as the ability to do work. Okay? So technically, work and energy are basically the same type of thing. But we can kind of sum it up with what's called the work energy principle, which says whatever net work we do results in a change in energy. For example, somebody who decides they're going to run. Okay, if you start running, you're changing chemical energy stored into your body into kinetic energy. And we haven't talked about this type of energy yet, but it's energy due to motion. Okay, you're transferring your chemical stored energy into kinetic. You're doing work. You're using a force to displace an object, yourself in that case. That's an example of how work and energy are actually related. Now, I also want to talk about whether or not work is positive or negative. Okay? So, sometimes it's easy to think of it as if work is being done on a system, then the work is negative. And if the work is being done by a system, then it's positive. Now, as an example, I've written one on here. It says a box sliding opposite of a friction force, because friction opposes the force. That force does work on the box, and it slows it down. Therefore, you are doing negative work. If it's slowing down, then that means the kinetic energy in this case would be getting smaller. That means you're doing negative work. However, if that net force, okay, is a positive net force, because if friction was acting on it, let's say this, we got friction this way, and a normal, and a gravitational, okay, if this is your net force, then that net force is in a negative direction, and it's working to slow it down if it's trying to move this way, okay. Alright, so that would be if our net force then was negative. However, if the net force is positive, okay, so let's say again if we drew this and we had some applied force and friction force this way where the applied force is much greater, okay, if that net force is a positive force, then we've done positive work. So I've written these couple statements here, and you can use them if you think it's helpful, but if the sum of the forces is a positive force, then we've got positive work. If the sum of the forces is negative force, then we've got negative work. Okay?